Okay, girls. So the next part of your homework was to do the questions on viscosity and density, which was also on the matter and mixtures theory file. The questions were on pages 8 and 9. So the first question reads, how is density affected by temperature in solids, liquids, and gases? Explain this in terms of the particle model. So if we have liquids and gases and we heat them up, what is going to happen? So the molecules are going to move faster. They're going to bump into each other and spread apart. This, in other words, is what we call that is going to be an increased kinetic energy. Therefore, we can say that they become less dense, okay? So if we had liquids and gases and we heat them up because the molecules are going to move faster and they're going to spread apart, that means that they're going to use less volume and that means that they're going to become less dense, okay? Let's think about solids. So if we have a solid and we heat it up, what is going to happen? It's going to melt. And if it is going to melt, then the volume is going to increase. Agree? So another way of explaining what I just said is to think about this. If we use our formula and we think that density is equal to mass over volume, and we're thinking that the mass is going to remain the same, but we're going to increase the volume. So what is going to happen to the density? It's a good way that you start getting used to using formulas to analyze this type of questions because it's going to be very useful later on for you in science, okay? So let me use a pen here. So I'm going to put some examples here, okay? So let's say that I have a mass of 10 grams and a volume of 5 cube centimeters. If I do that, what is going to be my density? My density is going to be 2 grams per cube centimeter. Agree? Okay, if I leave the mass, this doesn't, okay, if I leave the mass, it's the same as it says here. I'm going to leave the mass as remain the same, but I'm going to increase the volume. Let's see what happens. So I'm going to do 10 grams, but now instead of 5 cube centimeters, let's say, that is going to be, I don't know, let's say 8 cube centimeters. So what is this going to be? So if I do 10 grams divided by 8, I don't have it here, but I can use this. 10 divided by 8, 1.25. So this is going to be equal to 1.25 grams per cube centimeter. So what happened? It became smaller. It was 2 grams before, and now it is 1.5. So it became smaller. That makes sense because I have the same quantity and I'm dividing it by a bigger quantity. That means that if I have the mass and the mass remains the same and I increase the volume, what is going to happen to the density? The density is going to decrease. Okay? So in solids, if I heat them up, the volume will increase. Agree? And that means that the density is going to decrease, is going to become less dense. Okay? So all three states of matter, solids, liquids, and gases, will become less dense if they are heated. Okay, the second question says a liquid that is heated becomes less dense and it also becomes less viscous. What is the connection between these two properties? So, density and viscosity are two different physical properties. This looks terrible, but the idea is that I was underlying density here. So, this first line is underlying density and viscosity, just to show that there are two difficult physical properties, but it's very important that you highlight that they are different physical properties of a substance. They are related, but they're different. So what is density? Density talks about the number of particles and how tightly packed they are. Agree? And what is viscosity? Viscosity talks about how easily particles move around each other. So if we think about this, if a substance is very dense, it means that it has a lot of particles that are very tightly packed together. Agree? That will give them little space and little opportunity to move around each other. So the viscosity is going to be very, very thick. Agree? So both density and viscosity are affected by temperature, but viscosity changes rapidly. That means, for example, if you think about honey and you warm it up, it becomes easier to pour, right? So viscosity is affected by temperature very quickly, whereas density changes more slowly. It takes more time for those particles to start heating up and moving more and spreading up and having more volume. So the viscosity changes rapidly, but the density changes more slowly. Good. The third question says, what do you think will happen if you carefully put hot water and cold water into the same container? Use the internet to check your answer. So I posted this a video, a suggested video to watch in YouTube. So if you go into our playlist of matter and mixtures, there is a video there. The video that you have to watch is called hot and cold water experiment, and it's with two glasses of cold and hot water. The cold one is blue and the hot one is red. So I want you to pause here, watch it, and then come back to this explanation that I'm going to do now. Okay, so as you saw in the video, so they have cold water and they put blue color on it, and they had hot water and they put red color. If you think about it, before you had any idea about particle theory, if I ask you to predict what will happen, I think you could guess. If I put the hot water underneath, what is going to happen to the hot water? We know this by experience, by life. So if we have the hot water is going to start to evaporate, right? It's going to go up. We know this. The hot water is going to go up, up, up. Let me just take my pen. So it's going to go up. We know that by experience, agree? So if I put it underneath and I put the cold water on top, it's going to mix. Why? Because the hot water is less dense. Now, this is when the new knowledge comes, is that you are able to explain now from a scientific point of view why the hot water goes up. It's because it's less dense than the cold water. So the hot water is going to go up and the cold water is going to fill the space. So it's going to go down. So that means that it's going to mix together, and that's why the water becomes purple. But what happens if I have the hot water on top? If I have the hot water on top, the hot water will continue going up. Agree? It's going to try to go up. So because it's trying to go up, it's not going to mix with the cold water. So the cold water will remain at the bottom, the hot water will remain on the top, and therefore it won't mix. So I think it's a very visual experiment that helps you to understand this concept. Okay, question 4. Question 4 says, explain how a hot air balloon works. So again, I posted a video on our playlist. So please stop now and watch it and then come back here. Okay, so same concept that we did just with the water experiment. So what happens is that the hot air, because it's less dense, is going to try to go up. And that's why it raises to the top. And the cool water that is surrounding that hot air is going to be cooler. So that's going to try to go down. And that's why the hot air balloon is going to go up. And in the video, they explain how does it go out down. They release that hot water. They open up here so that hot water can escape, hot air can escape. And therefore, it will be filled with cool air and then it will come down. So very interesting things, and I hope you find this useful. Thanks, girls.